In this lesson, we're going to look at how we calculate formula mass and molar mass. Let's look at what we mean by molecular mass and molar mass. Molecular mass, which is also known as formula mass, is about the mass of a single molecule of something. If we have a molecule of water, we can find the molecular or formula mass of that by using the numbers on the periodic table. When we do that for water, and we'll talk about how we find that number, but for water it's 18.02 U, and that's the mass of one molecule. Remember, U is just an atomic mass unit. When we go over to molar mass, we're talking about having 1 mole of water. So we're talking about having 6.022 times 10 to the 23rd molecules of water. We still see that we have 18.02, but now we have different units. We have grams per mole. So 1 molecule of water has a mass of 18.02 U. 1 mole of water molecules has a mass of 18.02 grams per mole. Same number, different units. We can find the molar mass of an element or a compound. Let's first look at an element. And what we're looking at is having 1 mole of that element, which means we have 6.022 times 10 to the 23rd atoms of that element. We can look at the periodic number on the periodic table, 10.806 for boron, and a mass of 1 mole of those atoms has a mass of 10.806, and we put the units grams per mole with that. So 1 mole of those boron atoms has a mass of 10.806. For fluorine, we can do the same thing, 18.998 grams per mole of fluorine. If we were only talking about a single atom of boron, it would have a mass of 10.806 U, but we're talking about a mole of atoms, so it has a mass of 10.806 grams per mole, and molar mass always has units of grams per mole. For a compound, we're going to take the information we know about the elements and put that together. In this case, we're looking at a mole of molecules, which means we have 6.022 times 10 to the 23rd molecules. And I look at how many of each atom are in that molecule. So we have 1 boron and 3 fluorines in each molecule, which means we also have 1 mole of boron and 3 moles of fluorine in a mole of molecules. And I can get the numbers for those elements from the periodic table. We have 1 times 10.806 grams per mole for the boron, and 3 times 18.998 grams per mole for the fluorine. I do the calculation and add those two numbers together, and we find that the mass of 1 mole of BF3 molecules is 67.800 grams per mole. In this example, we were looking at a molecular compound, so we talked about it in terms of molecules. When we look at ionic compounds, we can't actually call them molecules. Molecule means this discrete molecule, so a water molecule, a carbon monoxide or carbon dioxide molecule. Remember that when we have ionic compounds, we have this array of ions that have a specific whole number ratio. Therefore, we call those formula units. If you see formula unit instead of molecule, we treat those very similarly. They're the equivalent term used for molecular compounds versus ionic compounds. So formula unit is the smallest ratio of those ions in an ionic compound. What is the molar mass of carbon in units of grams per mole? To find the answer, we simply look at the periodic table. We look at the atomic mass for carbon, which is 12.011, and we know that it has units of grams per mole because we're talking about a mole of carbon. Now let's put carbon in a compound. What is the molar mass of propane, which has the formula C3H8? We have 8 hydrogens, so we take 8 times 1.008 grams per mole, plus 3 times 12.001 grams per mole for carbon. We add those together and we get 44.097 grams per mole. So 1 mole of propane has a mass of 44.097. We always use molar mass with the units of grams per mole. We're going to use it as a relationship to help us get between grams and moles for a substance. How many moles of oxygen atoms are in 1 mole of aluminum sulfate? We know we have 1 formula unit. Remember, we use that term kind of interchangeably with molecule, but to be correct, we should call it a formula unit. We have 3 sulfate groups, and every group has 4 oxygen atoms. Therefore, there are 12 oxygen atoms per formula unit of aluminum sulfate. If we have 1 mole of aluminum sulfate, each mole of aluminum sulfate has 3 moles of sulfate groups, and each of those has 4 oxygen atoms. Therefore, 1 mole of aluminum sulfate has 12 moles of oxygen atoms. What is the molar mass of aluminum sulfate? We have 2 aluminum, 3 sulfurs, and 12 oxygens. We take 2 times the 26.982 that we find on the periodic table for aluminum, 3 times 32.066 for sulfur, and 12 times 15.999 for oxygen. We multiply those values out, and then we add them together to get 342.15 grams per mole.